Alright, continuing with what we were working on in example 12. 5k over k squared minus 4 minus, and again you have to be really careful when you've got subtraction, 2 over k squared plus k minus 2. We said anytime you have a squared term on the denominator, you have to factor. So we're going to have to factor both of these. The denominator of the first one factors into k plus 2, k minus 2. The denominator of the second one factors into k plus 2 and k minus 1. Then I always recommend rewriting it nice and clear. Give yourself space on either side of what you're writing. So we're going to have 5k over k plus 2 and k minus 2 minus 2 over k plus 2 and k minus 1. And you want to give yourself, like I said, a little bit of space on either side so that you can multiply on what you need. So if you look, they both have k plus 2, and color coding can help here. The first one has k minus 2 and the second one does not. So the entire second expression is going to be multiplied by k minus 2. So that now they both have k minus 2. And then the first fraction is missing k minus 1. So we're going to multiply the first fraction by k minus 1. So that can get a little messy. Again, give yourself plenty of space. If you write really big, you might need a separate sheet of paper so that you don't cram up your work. From here, we'll distribute the 5k. We'll distribute the 2. I'm going to keep the second expression in parentheses so that I don't have to try and worry about the minus for right now. So we've got 5k squared minus 5k. The subtraction is going to come down where it was. I'm going to use parentheses here for 2k minus 4. So this subtraction in the original problem, this one came down right there. So you really want to be careful with that. All over the common denominator, k minus 1 times k plus 2 times k minus 2. So from there, we'll distribute that subtraction. We'll have 5k squared minus 5k minus 2k plus 4. The biggest mistake is that sign right there. This negative also distributes to here, and so changing that sign is really crucial. Over again the common denominator, k minus 1. It doesn't go away, but it doesn't change. K plus 2, k minus 2. Then we can combine like terms, whatever you have. So the final answer here would be 5k squared minus 7k plus 4 divided by k minus 1 times k plus 2 times k minus 2. And I ran myself out of room there. Hopefully you can still see that. So your final answer is just an expression. I recommend pausing the video and trying example 13, as it is very similar to example 12. And that way you can really test your understanding before you get into your homework. Example 13 is very similar. We're going to factor the bottom of each one. We have a difference of squares and then just a regular trinomial. So we want to get those factored. Then we want to rewrite the problem. Be careful because it is subtraction. So we have t over t plus 5 times t minus 5 minus 3 over t minus 5 times t plus 2. From there, it's kind of a search and find and multiply on what you need. So the first one has t plus 5. The second one does not. So we're going to have to multiply on t plus 5. And let's see, they both have t minus 5, so we're good there. And finally, the first one needs t plus 2. So we're going to multiply on, oops, over sharpen these, t plus 2. And it looks a little messy. Hopefully the colors help so you can really see where I'm getting all this from. Then it's just a matter of cleaning up, watching your signs, and getting that numerator organized. So because it is subtraction, I'm going to keep the second part in parentheses and deal with the subtraction separately. So the first distributing, I get t squared plus 2t. The minus, again, comes from the problem. I'm not going to change that yet. This subtraction here, and then from the original problem. And then I'm going to use parentheses still, 3t plus 15 over the 3 pieces that make up the common denominator. Then I'll distribute the negative. So t squared plus 2t minus 3t minus 15 over, again, the common denominator. Gets a little tedious, but you have to keep writing it. And then I'll combine like terms for a final answer of t squared minus 1t minus 15 over t plus 2 times t plus 5 times t minus 5. And feel free to use extra paper, just because it depends on how big you write, but you want to make sure it's nice and neat and organized, and you can follow each step. Example 14 and 15 are the kind of the worst case scenarios. These are pretty big problems. You might need some backup paper for these because they get a little involved. And that's because there's a binomial on the top, not just a single term. So before we were just distributing and distributing, now we have to do a little bit more complicated of a process. So these last two examples are the most involved from this section. I would say from this entire chapter, these are the most involved problems. So we always start at the denominator. They both have trinomials that need to be factored. I have already factored these, but you should make sure you can factor these on your own. The first one factors into 2x plus 1 and x minus 5, and the second one factors into x minus 2 and x plus 1. Let me make sure that's correct. Nope, that should have a 6 in front of it. I apologize. That should be 6x squared. I just mistyped that. Alright, so that should factor into, let's try that again, 2x plus 1 and 3x minus 2. I think I fixed that in your version of the notes, but that should be a 6. Okay, then we're going to rewrite it. I'm going to rewrite it on this separate paper so I don't run myself out of room. So we have 2x minus 1 on top over the factored form 2x plus 1 and x minus 5. Plus, it's good that it's addition, makes it a little bit less tedious. And then we've got x plus 3, and then 2x plus 1 times 3x minus 2. Then we kind of see what we've got. They both have 2x plus 1, so we're good there. The first one has x minus 5, so the second one needs x minus 5. And finally, the second one has 3x minus 2, so the first one needs 3x minus 2. So that's the hardest part. Get the things factored, give yourself space, and multiply on what's missing. From there, because we have a binomial times another binomial, we're going to FOIL these together. And same thing here, we have a binomial times a binomial, so we're going to FOIL those together. So we FOIL by multiplying every term by the other. We don't have to do that on the denominator, we can leave everything as we see it. So let's see what happens. That gives us 6x squared minus 3x minus 4x plus 2. That's foiling the first one. Plus, and that addition comes from the original problem, so addition addition, addition. And then we'll FOIL this one. That's x squared minus 5x plus 3x minus 15. So that's a lot of terms all put together, all divided by the three pieces that make up the common denominator in any order. Just like that. Then your job is to clean up the numerator and combine like terms. Cleaning all that up, we should get a final answer. I'm going to write it back on the notes. Final answer of 7x squared. Then we've got this one, that one, and this one. Looks like that would be minus 9x. Then we've got a plus 2 and a minus 15, so minus 13. So again, just cleaning up all of those common terms over that same denominator, 3x minus 2, 2x plus 1, and x minus 5. So it's a very exhaustive process. I'm tired too, so don't feel too bad if that was a lot to take in. And that's because you have a binomial on top and it requires FOILing, which gives you a whole bunch of terms to work with. Alright, example 15 is the same idea. I encourage you to pause the video, try it on your own first, then play it back and see how you did. So let's see here. We need to factor, which you want to make sure you can do this on your own. I've already done the work, but you want to make sure that you can get those factored without my support. So that factors into 3x plus 1 and x minus 2. The second one factors into 3x plus 1 and 2x minus 5. And I like to rewrite it. I'm going to rewrite it on here so I get plenty of room to work. We're going to have 2x plus 3, and I would put that in parentheses, over 3x plus 1 times x minus 2 plus x minus 6 over 3x plus 1 times 2x minus 5. And you might want to label this if you're using scratch paper. I always forget to do that. But you want to be able to go find these later. This was example 14. Now we're on example 15. Okay. Then we'll multiply on what's missing here. They both have 3x plus 1. This one has x minus 2, so this one needs x minus 2. And then the second one has 2x minus 5, so this one needs 2x minus 5. And color coding be helpful there. Because we have binomials, we're going to have to FOIL, multiply each term by the other. And FOIL here as well, multiply each term by the other. Makes this a little bit more involved, and you'll get a big long string of values. The good news for these is that it is addition, so you don't have to stress too much about changing signs. If it is subtraction, then you have to change all the signs on the second half. But this is addition just to keep things a little easier. So that's going to give us 4x squared plus 6x minus 10x minus 15 from the first one, plus x squared minus 2x minus 6x plus 12 from the second one. So that central addition is where you want to make sure you're not messing that up. All of those over your common denominator, each of the three pieces in any order. Then we just have to clean up the top, and we'll get our final answer of 5x squared minus, we'll put all the x terms together. That's negative 4 and negative 8, so negative 12x. And then put our constants together, that would be minus 3. Over, once again, those three pieces of the denominator, 2x minus 5, 3x plus 1, and x minus 2. So that's how your final answer should look. So like I said, those are the worst case scenarios when you have binomials on top and trinomials on the bottom to the factor. Most involved. In scratch paper, extra paper is always encouraged, along with colored pencils or highlighters to keep straight everything you're working on, because they do get very complicated very quickly.